Hello students, welcome to the lockdown series. So we have done up till the pseudo forces, and I have explained you how pseudo forces work for Earth and other rotating objects. So today we will be starting a new chapter, that is our chapter 2 of Newton laws. Okay, and we will study about the inertia and the Newton laws of motion. But before we set into the Newton laws of motion, I would like to introduce you with the law of inertia, or it was also termed as Galilean law of inertia, and it was termed by Galileo. Okay, so before, it was believed that the motion of the objects, before even Galileo, it was believed that there are certain myths about the motion of the objects. During ancient times, it was believed that the motion of the object will happen because of the energy processed by the object. Okay, and it was also observably true that when you observe someone throw something, suppose you throw a ball, okay, and it go up in the air and afterward it's come down, and it was believed earlier that till the ball have energy, it will go forward, and after it loses the energy, it will come down. So पहले ये माना जाता था कि जब तक किसी चीज़ में एनर्जी है, वो तभी तक मोशन में मूव करती रहेगी, और उसके बाद वो जब उसमें एनर्जी ख़त्म हो जाएगी, वो नीचे आ जाएगी. It was certainly misappropriate, and it was corrected by Ptolemy, Ptolemy, in ancient Greeks, and it was corrected, and it was said that not energy, actually the driving thing behind the motion of the object are force. So force is required to keep the object in motion. Okay, not only force is required to start the motion, it is always and every time it was required to keep the object in motion, because until and unless there is withdrawn of the force will keep on acting on the object, only then it will be in motion. But then after it was given by Galileo that not only force is only required to just start the motion, फोर्स सिर्फ मोशन को स्टार्ट करने के लिए ज़रूरत होता है, एंड इट वाज invented, and it was actually termed by Galileo that only object force is required only to start the motion, and the body will keep on traveling on its particular path in a particular direction with the advent, only with the effect of this force, and it will not it is not required for the force to keep it in motion. Okay, it is only required to start the motion. So Galilean law of inertia, it was defined by law of inertia that it is an ability of body to retain its direction, either the position of rest or the position or the ability to move, that is motion. The ability of body to maintain its position of rest or motion is called as inertia. Basically, this ability is dependent on mass. The more heavy the mass, the more massive the object, more time it will take to change its state. So it is basically the ability of an object to change in states of rest. But it was actually redefined and recalibrated by Newton that not only force is required to keep the body in motion, to start the motion, it was a definition of Newton that a body continues to move in a particular state of rest or of uniform motion until and unless an external force is applied to it. So only an external force is required to change the state of motion of a body. If a body is at rest, it will follow its rest position, and if a body is at motion, it will continue to follow its motion until and unless an external force is applied to it. The external force will only change the course of the motion. Means if a body is moving in certain direction, the external force will change its path. Suppose the force is given here in this direction, and now it is going in this direction. Now you are giving force in this direction, so it will start moving in this direction. Okay, so an external force can only change the path of the motion of the body. Till then it will continue to move in the same direction that it is followed previously, or the state of rest that it was maintaining. So here it is given that the inertia, law of inertia, can define the three state, or one of the state of rest, one is the state of motion, and one, and very important, is the state of direction. So what do you understand by state of rest? The state of rest is if a marble ball in accelerated metro. So a marble ball keeping inside a metro will certainly start moving only if you are giving an acceleration, or you are accelerating the metro train. Okay, second, till then it was maintaining its state of rest. Okay, second, if the marble ball is decreasing in the speed. Suppose the body was in motion for a particular time, and suddenly the metro train is started decreasing the speed. Okay, so it was in motion, and now it will roll back, and the marble ball will continue to be in state of motion, which was previously, and now it will change in state of motion. Okay, and second is the motion inertia of direction, one which was followed by the car moving in the direction, and a person will feel an outward pull. That was the force inertia of direction. That was inertia that was explained in the previous part. Okay, so the condition to check the law of inertia, or the law of conservation of linear momentum, is that external force must be zero. So how can you make the external force zero? You can either see. So by this law, you know that this equation becomes force is equal to mass times acceleration, and by not providing the acceleration, you can make the external force zero. Only then it is applying the law of inertia. So F is a force. If force is constant, if a body is undergoing under a constant force, then mass is inversely proportional to the acceleration. That means mass is inversely proportional to the acceleration. If mass is increasing, then acceleration will decrease under a constant force. Okay, second case, if a mass is constant, then force is directly proportional to acceleration. So for a body maintaining a same mass, suppose 60 kg throughout, so if you increase the force, the body will be more accelerating. Okay, तो जब मास सेम रहेगा, तो जितना फोर्स बढ़ाओगे उतना ही एक्सेलरेशन बढ़ेगा. और थर्ड केस है कि जब एक्सेलरेशन ही कांस्टेंट हो जाए. सो एक्सेलरेशन कांस्टेंट होने से बॉडी जो है वो नॉर्मली कांस्टेंट फोर्स से ही मूव करता है अनटिल उसका मास बढ़े। इस केस में अगर बॉडी का मास बढ़ता है तो उसमें ज़्यादा फोर्स लगेगा। ठीक है, ओके। सो फोर्स इज़ अ वेक्टर क्वांटिटी एंड हाउ टू प्रूव इट? You can prove it by the following experiment. Suppose here a person is standing here and you are taking this direction positive and this direction negative. Okay, so if a person is standing here and suppose a force of 100 Newton is 1000 Newton is applied in this direction, and similarly a force of 1000 Newton is applied in this direction. So this force cannot add up and make it 2000 Newton. You know that the body will not move because two equal forces are acting on the body. So body will stand still. Okay, and why the body will stand still? You can show it by mathematics, that the force of plus 1000 Newton in this direction and the force of minus 1000 Newton this direction will cancels out. So this body will be in 0 Newton, so no force is acting on it. Okay, secondly, if a body is subject to a plus 40 Newton force in this direction and minus 90 Newton force in this direction, now where the body will move? Now the body will not move in this direction, it will not move in this direction, it will move in this direction, but with the force of minus 90 plus 40, that is 50 Newton negative. This negative sign implies the direction of the conventional direction taken, so it will implies the opposite direction. So this direction, if you keep it in the force is equal to mass time acceleration equation, so here the mass is 10 kg, acceleration you have to find out, and force is minus 50. So acceleration of minus 5 meters per second square, acceleration of minus 5 meters per second square will be the answer. So hence the direction of acceleration is same as the direction of force. पहला तो ये प्रूव हुआ कि फोर्स जो है वो उल्टी डायरेक्शन पे लगेगा, और दूसरा ये प्रूव हुआ कि एक्सेलरेशन जो है वो उसी डायरेक्शन में लगेगा जिस डायरेक्शन में फोर्स लगता है, और दोनों ही नेगेटिव होंगी डायरेक्शन ऑफ मोशन के। तो इस केस में एक्सेलरेशन जो है, इस केस में एक्सेलरेशन जो है वो क्या करेगा, बॉडी के मोशन के डायरेक्शन में अपोजिट लगने की वजह से जो स्पीड को है वो डिक्रीज़ करेगा। तो स्पीड जो है अब यहाँ पे डिक्रीज़ हो जाएगा क्योंकि एक्सेलरेशन जो है वो उल्टी डायरेक्शन में लग रहा है, और फोर्स भी उसी डायरेक्शन में लगेगा जिस डायरेक्शन में एक्सेलरेशन होगा। सो दिस वाज द एंटायर कंसेप्ट ऑफ ऑल द क्लासेस वी हैव स्टडीड टिल नाउ। ओके, we have also studied about the axial reaction law and the equal and opposite forces. So the action reaction law that we have studied earlier, we have not studied earlier. We know that every action has an equal and opposite reaction according to the Newton law. So all the Newton laws are stated. The Newton first law is definition about inertia. The Newton second law is the definition about rate of change of linear momentum, and the Newton third law is the action reaction pair. So when you push an object, the object, you apply force on an object and this object retaliates by applying the same force. So F1 is equal to F2 but in negative direction. So the action reaction law states that both the action are equal and opposite. Okay, they are simultaneous. ऐसा नहीं होगा कि एक हो रहा है और एक 10 मिनट बाद हो रहा है. They act on different bodies. ये important है. This first action will be on first body by the second one, and the second action will be on the second body by the first one. Okay, so they act on different bodies, and these action reaction forces never actually cancels out. Okay, and they act on the same surface if contact forces. Okay, so there are different kind of force. If the forces are in contact with each other, and which is necessary condition for action reaction pair, they have to be in contact, point of contact, so they act on same surfaces but on different bodies. Okay, if you're thinking that they are cancels out, so I can show you the example that in a plane surface the reaction part and the action part may appear to be cancelled out, but this is not because of the action reaction pair. This is because of the friction of the body unable to move, motion of the friction. Okay, and the same in magnitude. If you apply this in an inclined plane, so here the action force is here mg, now the reaction pair is here, so not necessarily they are always in cancel out position. Here you can see that the body will slide down. Okay, so they not always cancel out. Okay, second, now what is the difference between action reaction pair of Newton's third law and centripetal and centrifugal force? Here you can see that moon is rotating around earth, so moon is experiencing a centripetal force due to gravity towards its center, so this force of gravity, and a centrifugal force as explained in earlier classes. But this centripetal and centrifugal force are opposite to one another. Okay, but this is still not an action reaction pair because this is only acting on the moon, so one body is there, but the action reaction pair are acted on different bodies. Okay, so here you can see an example of earth falling over the an apple falling on the earth, so you can see that how you can measure the acceleration of an object, and the mass of the apple is negligible, therefore the motion of the earth is not considerate or considerable depending on the motion of the apple. So the inertia of earth, because of the heavy inertia of earth and irresistible and resistance to the change its direction of the motion or its motion, you can see the object falling actually on earth, while earth will not able to move due to its inertia. That is why object falls over the earth, and that is called as gravity. Thank you.